This is the lecture for Lesson 5. This section is going to cover all sorts of types of factoring polynomials. In this first group, we're just going to work with the greatest common factor and some trinomials. The first type of problem we're going to do is work with the greatest common factor. So this is going to be the first thing we look at regardless of our problem. We always want to make sure none of our terms have anything in common that we can factor out first. So to find a GCF, the goal is to look at the largest number and the largest amount of variables that we can take out of all terms. Looking at the first one, we have 20x to the fourth minus 8x squared. So if I'm thinking about 20 and 8, I want to think about what number I can divide them both by and the largest number. So the largest number I can divide them both by is 4. And then this one has 4 x's, this one has 2 x's. So I can take out x squared, 2 of the x's. So then what I'm going to do is I had 2 terms to begin with, so I have to fill in those 2 terms, something minus something. And the way I do that is I figure out what is left by dividing. So I had 20x to the fourth, I'm going to divide by 4x squared. Well, 20 divided by 4 is 5. I had 4 x's, I took out 2, so there's still 2 left. And then 8x squared divided by 4, well, 4x squared. 8 divided by 4 is 2. I had x squared, I took out x squared, so that's all that's left. I can extend it to 3 terms, 4 terms, however many terms I have. So the next one, 9x to the fourth plus 18x cubed plus 6x squared. So looking at the numbers 9, 18, and 6, they're all divisible by 3. And then looking at the x's, I have to take the smallest one, so x squared. Now this one's a 3 term, so I'm going to have something plus something plus something, and I'm going to fill in all the blanks. So 9x to the fourth is divided by 3x squared. 9 divided by 3 is 3. I had 4x to the fourth. I took out 2 of them, so there's 2 left over. 18x cubed divided by 3x squared. 18 divided by 3 is 6. I had 3 x's. I took out 2, so there's 1 left over. 6x squared divided by 3x squared. 6 divided by 3 is 2. I had x squared. I took them all out, so there's no x's remaining. Last one, 15x to the fourth y to the sixth minus 3x to the third y to the fifth plus 12x to the fourth y to the fourth. So looking at the numbers, 15, 3, and 12 are all divisible by 3. And then we need to look at the x's. So I have x to the fourth, x to the third, x to the fourth. So I can take out the smallest, x to the third, and then work with the y's. Y to the sixth, y to the fifth, y to the fourth. So y to the fourth is the smallest. So I'm going to divide all of these by 3x cubed y fourth. 3x cubed y fourth, 3x cubed y to the fourth. So 15 divided by 3 is 5. I had 4 x's over 3 x's, so there's 1 left. 6 y's, take out 4 y's, 2 left. Carry the minus. 3 divided by 3 is 1. All the x's got taken out. I had 5 y's, I took out 4, so there's 1 y remaining. 12 divided by 3 is 4. X to the fourth, I took out 3, so there's 1 x remaining. Y to the fourth, I took out all the y to the fourths. So that one is done. The next is working with a trinomial with no coefficient on the first term. So there's no number in front of that first x squared piece. When you're working with these, our goal is to find 2 numbers that add to the middle and also multiply to the end number. So for this first one, we're looking for 2 numbers that add to make -6, and those same 2 numbers multiply to make 8. So there's only 2 ways to make 8, 4 times 2 or 8 times 1. the only way that we're going to get to 6 is with 4 and 2. Now, I need to get to -6 though. So I need -4 and -2. -4 plus -2 makes -6. And -4 times -2 is +8. So the way that I write this answer is these values, x minus 4, x minus 2. So x and then the first value times x and then the second value. Next one is x squared minus 3x minus 18. So for this one, we're looking for the two numbers that add to -3, and those same two numbers multiply to -18. So it's always add to the middle, multiply to the end. So thinking about 18, we've got 9 and 2, 6 and 3, 18 and 1. So the only pair that with adding I'm going to get to 3 is at 6 and 3. So if I have, let's see, I want to get -3. So -6 plus 3 is -3. -6 times 3 is -18. So this one is x minus 6 and x plus 3. Last one here, we're going to add to 9 and multiply to 20. So two numbers that add to 9, those same two numbers multiply to 20. So 20 is 1 and 20, 2 and 10, 4 and 5. The pair that can add to 9 is 4 and 5. 4 plus 5 is 9. 4 times 5 is 20. So x plus 4, x plus 5. All right, so your helpful suggestions for how you're going to do this, the two things. So usually what I do is I list my multiples of the end number. So how am I going to get 6? So 1 and 6, 2 and 3. The next thing you're going to do is you're going to use those pairs to find which one is going to get us to the middle number. So which pair can make the middle? So what if we no longer have a 1 in front and we now have a number? Well, we're going to kind of follow, at least to start, that same process, but it's going to be a little different. So in order to find what we multiply by, you're going to take first times last. So 5 times 3 makes 15. So the multiplication problem is going to be 15. The middle is still that addition piece. So we want to multiply to 15, but add to -16. So the way that I'm going to do this is -15 times -1 and -15 plus -1. Now, what I'm going to do is I'm going to rewrite this problem as a 4-term problem using these pieces here. So 5x squared is going to come down. I'm going to rewrite -16x as -15x minus 1x. So we agree that -15 minus 1 makes -16. And the reason I'm using that pair is because it works to make this multiplication problem true as well. And then carry down the +3. What I'm going to do now is I'm going to do GCF of each side. So I'm going to look at the first two terms and figure out what I can take out. So 5x squared and 15x. I can divide each of those by 5, and I can take out an x. 5 divided by 5 is 1. X squared, take out an x, is x. 15 divided by 5 is 3, and I took out the x. Now, what I want to have happen is this to match over here. I want to have 1x minus 3. Well, right now I have -1x plus 3. I have the wrong signs. So if I take out a -1, it will make it work, because -1 times 1x is -1x. -1 times -3 is +3. So now what I have is very close to my answer. I I have this piece and this piece, and they share this term in common. The 1x minus 3 is one of my factors. And then the remainders, the 5x minus 1, what's in front, is going to be the second half of my answer. So let's try two more, and hopefully as we do some more here, it'll make a little more sense. Okay, so for B, 6x squared plus 19x plus 15. To get our multiplication, we got to do 6 times 15. So we need to find what times what equals, well, 6 times 15 is 90. And the middle number is 19. So what plus what equals 19? So on the side, you can work with how do I make 90? 1 and 90, 2 and 45, 3 and 30, 6 and 15, 9 and 10. And if I look at that, well, I know 9 plus 10 makes 19, so that should work. 9 plus 10, and 9 times 10. So what I'm redoing is I'm going to rewrite this middle term, 19x, as 9x plus 10x. So 6x squared plus 9x plus 10x, and then plus the 15. So I'm going to break it into the 2 halves and do GCF of each side. So for 6 and 9, I can divide them both by 3, and they both have an x. So 6 divided by 3 is 2. I had x squared. I took out an x, so there's 1x remaining. 9 divided by 3 is 3, and I took out the x. Okay, remember the goal is that we should end up with 2x plus 3 over here. So if I'm thinking about this, 10 and 15 are both divisible by 5. So let's double check. 5 times 2 is 10. 5 times 3 is 15. I did it correct. So then my first answer is this parentheses piece, the 2x plus 3, what they have in common. And the second half of my answer is what's left over, 3x plus 5. All right, so last one, 4x squared minus 27x plus 18. So if I multiply 4 times 18, that gives me 72. So two numbers multiply to 72. Those same two numbers add to negative 27. Okay, so I'm looking for numbers that make 72. I've got 2 and 36, 3 and 24, and I'm just doing a division. So take 72, and then you try to divide by 4. Okay, 4 times 18. It's not going to divide by 5. 6 and 12, 8 and 9. All right, so which pair, when I add them together, can get me to 27? Now, I know I need negative 27. So 3 plus 24 gives me 27. So if I make them both negative, negative 3, negative 24, I should get negative 27. And I know a negative times a negative is a positive. So I'm going to rewrite negative 27x as negative 3x and negative 24x. So 4x squared minus 3x minus 24x plus 18. Break it in half. 4 and 3 are not divisible by any number, but they do share an x. So I'm going to take out an x. So I'm left with 4x minus 3. So I know over here I want to get 4x minus 3. So how did I do that? Well, if I take negative 24 divided by 4, that gives me negative 6. So negative 6 times 4x is negative 24x. Negative 6 times negative 3 is positive 18. So I know I did it correctly. We have the 4x minus 3 in common. And my leftovers are x minus 6. So there's my final answer. This next section is going to look at some special trinomials. And all that means is we're going to end up with, in this first set, where we have the exact same answer. So maybe it's x plus 2 and x plus 2. And then we're going to look at difference of squares, where that gives you x plus 2 and x minus 2 as an answer. You can see here we do have a formula that we could follow. We can see if they're all positives here, a squared plus 2ab plus b squared. It should make a plus b quantity squared. And if that middle term instead is negative, it should make a minus b quantity squared. You don't really have to memorize this. We can just keep using the process we were using already. All right, so let me correct what this is supposed to say. X squared minus 6x plus 9. All right, so the first one we're going to look at is x squared minus 14x plus 49. So thinking back, this is just a 1 in front. So I'm looking for the two numbers that multiply to 49 and those same two numbers add to negative 14. Well, there's only two ways to multiply to 49. 1 and 49, which aren't going to add to 14, 7 and 7. Now, the trick is, though, I want to get negative 14 when I add, so I need both of these to be negative. So what happens in this one is I get x minus 7 times x minus 7, or x minus 7 quantity squared. Next one, x squared minus 6x plus 9. So we're looking for the two numbers that multiply to the end number 9, and those same two numbers add to the middle number 6. So 9, 3 and 3, but we want to get negative 6. So I need to make them both negatives. Again, because the coefficient is 1, I can go straight to my answer. So x minus 3 times x minus 3, which is x minus 3 quantity squared. So how are you going to recognize these if you recognize them? Well, the dead giveaway is that end number has to be a perfect square. So remember, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and so on are all perfect squares. And the second part is if you square root that number, so the square root of 9 is 3, that those two numbers repeated make up your middle number. But again, if you don't recognize it, you just go back to the method of what pair multiplies and adds, and you're still going to get the same answer. This next special case is called a difference of squares. Now, a difference of squares has to only have two terms first off. Then it has to have a subtraction, and they both have to be perfect squares. So this first term is a perfect square, the second term is a perfect square, and there has to be a subtraction between them. The results you're going to get are a minus b and a plus b. And we looked at this with the conjugates before when we were talking about leaving that square root in the denominator. We can't do that, how we rationalize it. So what happened was when we multiplied these out, those middle terms disappeared, and we only ended up with the first one squared minus the last one squared. So if you have a squared minus b squared, you're going to have a minus b times a plus b. You have to have two different signs for a difference of squares. So when you look at this first example here, determine whether the following statement is true or false. If the statement is false, make the necessary changes to produce a true statement. 4x squared minus 121 equals 2x minus 11 quantity squared. Did we follow the formula up here? No, we did not. 4x squared minus 121. They are both perfect squares. It's going to give me 2x and 11. But to follow the rule, it's 2x plus 11 and 2x minus 11. One has to be plus, one has to be minus. It doesn't matter which one you write first. I do realize that if they have the minus one up here first, I always default to the plus one first. That's just the way I've always done it. So let's try some more. Factor 4x squared minus 9. 4x squared is a perfect square. 9 is a perfect square. So 4x squared is 2x times 2x. 9 is 3 times 3. One gets a plus, one gets a minus. 16 minus 49x squared. 16 is a perfect square. 49x squared is a perfect square. So 16 is 4 times 4. 49x squared is 7x and 7x. One gets a plus, one gets a minus. And the last one, 64x squared minus 25y squared. Both of those are, again, perfect squares. 64x squared, that's 8x times 8x. And 25y squared, that's going to be 5y times 5y. One's a plus, one's a minus. If you're wondering how I'm getting these, I'm just thinking to myself, what times itself makes 64, 8 and 8? What times itself makes x squared? So split the x's in half. 1x here, 1x here. The other way to think about it is you could square root 64x squared, and you should get 8x, and that's what's going in each of those two places. The next problems we're going to factor are problems with third powers. So we're going to see problems that we'll do by grouping, and then some special cases, which are the sum and difference of cubes. These first ones want us to work by grouping, which we've already done. Anytime we have 4 terms, that's usually our giveaway to grouping. So recap a little bit with us here. 2 terms is probably a special case. So far, the only special case we've learned is a difference of squares. But in a little bit here, we're going to see sum and difference of cubes, and there's still going to be 2 terms. When you have 3 terms, that's your trinomial. You're looking for your what adds to that number and then what multiplies to the other number on the end. When you have 4 terms, the general rule of thumb is to do grouping. So you're going to look at the first 2 terms and the second 2 terms and factor out GCF and then go to your answer. So if we look at this first one, x cubed minus 2x squared plus 5x minus 10. We're going to look at the first 2 terms together. So no numbers in common. There's a 1 and a 2. So I can't take out any numbers. But I can take out x squared. So I had 3 x's. I took out 2. There's 1 left. The negative 2 is still here, but I took out all the x's. Now, remember, on this other side here, I should end up with x minus 2. That's why I do grouping, because I want to have this to be left. So if I think about that, well, looking at 5 and 10, I can divide them both by 5. If I take out 5, 5 times x is 5x. 5 times negative 2 is negative 10. So I did it correctly. Now comes the final answer. Well, the common piece now is x minus 2. And the second part is what's left over, the x squared plus 5. All right. We can look at the next one, 3x cubed minus 2x squared minus 6x plus 4. So first two terms, 3 and 2 cannot divide by a number. But x's, I have x cubed in the first one, x squared in the second one, so I can take out x squared. So the 3 is going to stay. I had 3 x's, I took out 2, so there's 1 left. The negative 2 is going to stay. I took out the x squared. We know over here we want to get 3x minus 2. And right now I have negative 6x plus 4. So what did I take out here to make this work? Well, I had negative 6x, and I want to have a 3x here. So negative 6 divided by 3 is negative 2, and the x's cancel out. So let's make sure that next part works. Negative 2 times negative 2 is positive 4. Yes, we are correct. So 3x minus 2 is the first half of our answer, and x squared minus 2 is the second half of our answer. The next problems are sum and difference of cubes. Now our cubes, cube numbers, 1, 8, 27, 64, 125, 216, 343, and so on. So 1 to the third power, 2 to the third power, 3 to the third power, 4 to the third power, and so on. What we're going to have is they're either going to be added or they're going to be subtracted, but they both have to be perfect cubes. And then we're going to follow this formula here, that the way we factor them is, and you'll look, it looks almost identical. The only difference is going to be the signs and where are positives and negatives. So in the plus one, it goes plus, minus, plus. In the minus one, it's minus, plus, plus. So the trick to doing that is it's called SOAP. So the same sign, the opposite sign, and then always positive. So if you have a cubed minus b cubed, you're going to start with the same sign, minus, then the opposite sign, plus, and then always positive on the end. So let's factor 27y cubed plus 1. So what we need to do is we need to figure out, well, what's the a piece and what's the b piece? Well, we need the cube roots. So the cube roots of each piece is what I need to figure out. So the cube root of 27y cubed, that's going to be 3y. And the cube root of 1 is 1. So now I'm going to fill in what I have. So the a is the 3y, the b is the 1. So 3y plus 1. Then it's going to be this first piece squared. So 3y squared, well, 3 times 3 is 9, and then y times y is y squared, minus, multiply a and b together. So 3y times 1 is 3y, and then plus the second term squared. So 1 squared is 1. There's no other way to do these besides using the formula. Looking at b, I have 216x minus x to the fourth. And you may look at this and say, okay, wait, I thought we were working with third powers here. And this one has a fourth power. Well, here's one thing they did. You always, always, always should check for a GCF before doing your problem. And that's what happens in this one. So they both have an x that I need to take out. So if I take out that x, now I have 216 minus x cubed. And now I have my cube part. So 216, this is 1 cubed, 2 cubed, 3, 4, 5, 6 cubed. So 216, a is going to represent 6. And x cubed, that means b is going to be x. Now, I cannot forget that that x was out front. So I'm going to carry the x over and then go from there. So a is 6 minus b is x. All right, now comes a squared. So 6 squared is 36 plus 6 times x is 6x plus this one squared, 6 squared, or sorry, x squared goes there. So as long as you can figure out what the cubes are, the cube roots, you can then follow the formula. And again, for any quiz or homework in here, you don't have to have these memorized. You'll be able to have the formulas in front of you. Number 3, determine whether the following statement is true or false. If the statement is false, make the necessary changes to produce a true statement. We have x cubed minus 27. So I'm going to take the problem on the side and I'm going to work it out my way. So x cubed, that means a is x, and 27 gives me 3. 3 cubed is 27. All right, so the rule is a minus b, so x minus 3, a squared, so x squared, plus, multiply these two together, 3x, plus 3 squared, 9. Do they match? No, they do not match. So this one is false. It should be 3x, not 6x. The last little bit here is going to have a fraction and negative exponents, and then just working with, again, greatest common factor, maybe combining greatest common factor with another special case. First problem says to factor 2 times the quantity 3x minus 1 to the 3/4 plus 5x times the quantity 3x minus 1 to the negative 1/4. As you look at this, you see two things. You see negative exponents and you see fraction exponents. This is not a very common thing we're going to see. So we're going to go through these two examples and that's it for these. You're going to see the other ones a lot more frequently. The rule here is you want to take out the largest negative exponent. So we're going to work through it. And if you have questions, which I'm sure you might, these are definitely ones we can work on in class when you come and we work on this section. We have two terms in this problem. And right now, the piece that they have in common is that 3x minus 1 raised to a power. According to what we need to do, we're going to take out the larger negative exponent. Well, this first one has a positive exponent. The second one has a negative exponent. So we're going to take out that negative exponent. 3x minus 1 to the negative 1/4. All right, so we know we're going to have 2. We took out part of this 3x piece, but we didn't take all of it out yet. So I'm going to talk about how we get that exponent in just a second. I'm going to write what we have left, though. So the 2 was left. We've got this piece, and then we've got this plus 5x piece here. All right. We had 3/4, positive 3/4, and we wanted to take out a negative 1/4. I didn't have any negatives to begin with. So I want you to think about this. I have 3/4 currently in here. I want to be able to take out a negative 1/4. I want to take out a negative 1/4. Well, in order to be able to take out a negative, I need to have a negative. So if I'm going to put a negative up here, I also need to put its opposite, a positive 1/4. Because if you think about it, I have to keep this term the same. So 3/4. If I add a 4th to it and subtract a 4th, I'm still going to have the value of 3/4. I hope you agree with that. So thinking about this is 3/4 plus 1/4 minus 1/4, which is still equal to 3/4. I can now take out that negative 1/4. So if I take that out, what I'm left with now is 3/4 plus a 4th, which is 1 whole, which works out really nicely because now this inside, I can do a little distributing and simplifying. So keeping the outside as it is, Let's distribute that 2 in. 2 times 3x is 6x. 2 times -1 is -2. And then we have plus 5x. So 3x minus 1 to the -1/4. And then combine our x's. 6x plus 5x is 11x minus 2. So let's look at B. 4x to the -5th minus 7x to the -2. According to the rule, we're going to take out the larger negative exponent. So that's going to be to the -5th. So if I take out the x to the -5th, I still have a 4 here. I didn't take out the -7, and I need to figure out the power on this guy. So I currently have -2. And I want to take out -5. Well, in order to take out -5, I would have to add 3 more negatives. But I have to keep this an equal statement. So that would also include 3 positives. So keeping this as a true statement, -2 minus 3 plus 3 is still -2. Now, why did I pick -3 and plus 3? Well, because I need to take out -5. I now have -5 to take out. What's left? A positive 3. And that is the final answer for this one. Again, if you guys have questions on these, we can do your homework problems in class from this section. Don't be afraid to ask when you come back to class. Combining all together. Factor each expression using the greatest common factor and then other techniques. So they're telling you there is a GCF first. And after you do the GCF, make sure there's not anything else you can do, because sometimes we have a combination of problems. Like we did on that cube problem, we factored out an x to make it a cube, and then we did the cube formula after that. Looking at A, -5x to the third plus 50x squared minus 10x. So just looking at the numbers, 5, 50, and 10, they're all divisible by 5. Now, personally for me, I don't like leaving this first term negative. So what I'm going to do is I'm going to pull out a -5 just because for me that makes just the most sense for me. If you did +5, it's okay. It's not going to mark it wrong. Now we look at the variables. All of them have an x. All right, -5 divided by -5 is +1. I had 3 x's, I took out 1, so there's still x squared left. I'm going to have to change that sign because 50 divided by -5 is going to leave me with -10. I had 2 x's, I took out 1, so there's still an x left. -10 divided by -5 leaves me with +2, and I took out the x. So now I'm left with a trinomial. 1x squared minus 10x plus 2. So the trinomial rule, I want to check and see, can I add to the middle number and multiply to the end number? Well, is there any way to multiply to 2 and then also add to -10? I'm going to say no, because the only way to multiply to 2 is 1 and 2, and there's no way to add 1 and 2 to get to -10. So this one is in fact done. There is nothing more than a GCF for this problem. Looking at B, 14xy minus 10xz plus 8xw. Well, I see that all the numbers are even, so I know I can at least divide them all by 2. And as I was reading them, I read an x in every single one of them, so I'm going to take out an x. 14 divided by 2 is 7. I took out the x. There is still a y. -10 divided by 2 is going to be -5. I took out the x. There is still a z. 8 divided by 2 is 4. We took out the x, but there is still a w. Now, all 3 terms are different variables, so there is absolutely nothing else that we can do with this problem. This one is done. Last one, 5x to the fourth minus 20x squared. Well, if I look at 5 and 20, I know I can divide each of them by 5. I have 4x's here, 2x's here, so I'm going to take out 2 of them. 5 divided by 5 is 1. X to the fourth, I had 4, I took out 2, so there's still 2 left. And 20 divided by 5 is 4, and I took out the x squared. All right, I got 2 terms. When I'm left with 2 terms, I have to see if this is a special case. So we either have perfect cubes or perfect squares. 1x squared and 4 are perfect squares. So we have a difference of squares here. And the way we did those is 1 was plus, 1 was minus. So x squared is x times x. 4 is 2 times 2. And when it's a difference, 1 gets plus, 1 gets a minus. And that is the end of this section. So you can go ahead and start the homework for this section.